Gender Pronoun Resolution Challenge. Today, I wanted to actually review results from predictions from the trained model and then finally be able to make a submission. So I actually have some coworkers in today, and so this will be an opportunity to sort of get real-time feedback on what I'm doing and explain things better probably. So I'm gonna continue with the notebook that I've been working on. It's public, available on Kaggle, and whenever a like Jupyter notebook or this Kaggle notebook is restarted, I actually lose all of the progress that I made. So I'm actually gonna have to execute all the code first so that, and train the model. It doesn't take actually that long, thank goodness. And then, yeah, retrain the model because the environment doesn't keep like the folders that I generate. So that's why I have to retrain the model.
And this is your fine-tuning BERT model?
Yeah, it's fine-tuning a BERT model using actually Squad. So like, so the competition is about like predicting which noun does a pronoun refer to. So I actually had the idea, so like I really like BERT, so I just decided like, how can I formulate this problem as a BERT problem? And the one that came to mind for me was actually a question answer. So given if we...
Can we go to the BERT GitHub page where they talk about Squad?
Yeah, so it's a question answering data. We can actually just go to the paper.
Question answering.
Yeah, exactly. The Stanford question answering data set. Squad. So if we go to the paper, I think the paper does a really good job of formulating the problem and how they decide to like, try to solve it. So in the paper, they actually talk about each of the architectures used in order to solve each of the tasks that were, attempted. And so for the Squad data set, for the Squad question answering test, what you do is you actually have a set of tokens as input, and then the first set of tokens are the question, and then you have a separator, and the second set of tokens is the paragraph. And the paragraph is the actual like block of text in the paragraph. So an example would be the input question: where do water droplets collide with ice crystals to form precipitation? You input the paragraph, and then what happens is the model will actually highlight where in the paragraph the question is answered. So my idea was to say, if I actually look for the Squad example, no, that's not it. I can actually close that. So if you do for Squad example, the question text that I say is which noun does the pronoun refer to? And then the paragraph text will actually be the text from the actual, so be here. He had patronage from French, et cetera, and then the question I would ask is, which pronoun does his refer to? And there's definitely some weaknesses to this. So if there's multiple his pronouns in the paragraph, the nice thing is, but the nice thing is I have like candidate answers. So then my idea was, given the prediction, right? So even if the model highlights none of the text or refers to text that's neither A nor B, then you would say that the answer is neither. And then if it highlights even one A or B, then that is the answer.
Are A and B always the same gender?
I don't know. I haven't actually looked. Looks like it. William John.
This is the training data set we're looking at?
Yeah, this is the training data set that we're looking at. And I actually, so this is actually how I create the training data. I read the tab separated CSV, and then I actually apply this get squad attributes function in order to extract the doc tokens, chart a word offset, orig answer text, start position of the answer, end position of the answer. And I made it all one data frame, and you can see what that looks like. So the chart a word offset is which character, for each character, which index word in the doc token does it refer to, right? So the first 3 characters refer to he, the next 4 characters refer to had, so on and so forth. And then the start position is, you would say, the 36th token in this chart a word offset. So this is the word number. Yeah, and that's generated based on the pronoun offset, which is, this is character offset. You look that up in the chart a word offset, and that generates your start position, which is calculated based on like the length of your answer text.
Sure. So it's just.
Yeah, so like John Wadsworth is 2 words, so that's 39 and 40.
And in general, your A and B offset are always going to be greater than your word offset, because you don't refer to someone as he until you say.
I mean, pronouns can actually refer forwards and backwards. So if the pronoun's at the beginning of the sentence, it can refer.
Because of his enormous bowel movements, Sir John Wadsworth invented the toilet.
Yeah. So I can run over the notebook again, review the notebook, so yeah, right now it's currently training, and this doesn't take too long. It takes like a couple of minutes.
So the task essentially is semantic rule labeling, right?
Semantic rule labeling.
Yep. If you go to, I think it was Ron Colbert,
Oh, that the VDC and that stuff?
No, it's before that. It was from 2015, I want to say. But
oh, for each word, what part of the sentence does it refer to? Or is it?
Oh. So semantic role labeling is specifically like proper nouns.
Okay.
What's the subject? What's the object?
But how does, given the semantic role label, how can you, what would this look, how would you know that he refers to, or like, how would you know that he refers to like another noun?
I don't know.
Okay.
Answer is, I don't know. It's essentially like parts of speech tree reduction. There's probably some kind of like, weird Adobe decoding type thing in there, like a CRF or something. So you get like the most likely path. The first exposure I had to it was, I think it was Ron Colbert's paper, where he does starts with like parts of speech tagging, then he does semantic role labeling from there, then he does named entity, and then he's talking about classification.
Interesting.
All of this portions.
So yeah, it actually, in that short amount of time, what was it, like a couple of minutes, we've actually finished training the model. So that was like a couple of minutes.
Again, though, you're not training, you're fine tuning.
Fine tuning, correct? Yeah. Fine tuning. Thank you for that.
You're welcome.
Clarification. Yeah.
What's up, YouTube?
Definitely. So yeah, a lot of plumbing in order to get the squad data set. Not a lot of plumbing, just some plumbing. Thank goodness the BERT model actually has like a standard API. So for instance, like each of the tasks have like input examples, or the other one is like a run config, or a model function builder, a TPU estimator. So like a lot of that is straightforward, plug and play, input function builder. That's all. Yeah. That's all fine.
I remember with the classification thing, if you want to do that, it's like you override like 2 methods, then change like one other line of code because you specify task.
I actually found what's it called? I actually found like a Medium blog post that did the multi-classification, but multi-label, but it was in PyTorch, so that wasn't really useful for us.
PyTorch and BERT.
Yeah, there's been ports of BERT to PyTorch.
So I mean, if we get time and give a crap, that needs to be there. Like I can show you where the code needs to go. It's just an issue of like, you're essentially changing softmax cross entropy to sigmoid cross entropy. Those are the names of the functions. But as a like corollary of that. I don't know if I'm using that word correctly, but you know, one of the side effects of that is that you need to calculate your accuracy or your loss or whatever. You need to see, was I right? And that calculation is different. And instead of the argmax, you need to do the you need to round your entire output vector.
Interesting.
And it can have, you know, different consequences.
I don't understand if is training D batch return D. There's no for loop. Oh, the for loop is actually, oh, so this actually.
That's defined inside the for loop.
Oh man. So yeah, so this notebook is actually based off another notebook that I found.
Really?
Yep, you know, I really love copy pasting. So for loop and then def.
But,
so oh, the input function actually returns D.
okay.
And then at the end of the input.
The bottom is not indented.
So this is all, so this should be indented a little more because this is inside the input function. And then this is returning the input function. So boom, copy paste. So this is, I'm able to generically use this because this is just actually referring to the, these are the parameters that the BERT model is using as input representation. So like input IDs, mask, segment IDs, label IDs, these parameters are actually used across all, like for all BERT models, no matter what. So I can pretty much just cut and paste that. Then there's this create examples function. Test. So yeah, I haven't done this part. Create examples. So if the type is train, then you're actually going to, oh, you know what? I don't use this function anymore. Because what I do is I do this. I actually inline. This is what happens when you like.
Don't use Git.
Yep. You just like forget about everything you ever done.
It's a production Jupyter.
That's right. This is hardcore. So the train data set is built from a, is actually built from like scikit-learn test train split. Where is that? It's probably right here. Test train split. And so the train is, and the train and test are like not ready for input into the model. They're the components that you need to create your pretty much the squad example is used to create TF records. So I'm going to create another function.
Can we go up?
Create point.
Where you actually call the BERT model. Because this is, so I've used BERT as a classifier in like other stuff that I've done. And essentially you give BERT a task. Like that's how it works. Like BERT is not just like run training and then give it hyperparameters. There's a bunch of shit you have to do to get it to like, you know, even get off the ground. And I want to see, so you specify school, like, was it run squad.py, and then you specify this task, the SRL task?
So what happens is there's actually, in the repo, the original research repo, there's actually a run squad code.
And then run squad, so essentially what you're doing, like effectively what you're doing is the same as going into that run squad and then
changing shit in here.
Yeah, but it's not the parameters. It's like those classes that are being defined.
Yeah, so what you need to do is you actually need to create a new like data processor. Yeah. There should be like a processor. Nope, there isn't. I don't know how to spell processor wrong. What happens is this data set, the squad data set, it's assuming a very specific data set, right? This is a well-known. So this parsing of a JSON file for the squad data set is built for that data set. So I modified this input features function.
Okay.
I'm effectively modifying this input features function class so that, and specifically the read squad examples function.
So this is not as compartmentalized.
No, yeah, the classification one is a lot more, what's it called, modular, which allows you to extend. Yeah, classification extends a lot easier than a question answering data set. Yeah. So yeah, where was
And then
I?
just to summarize, because I've only been paying like
2% attention. Sure.
I was gonna say 25%.
Oh wow, thank you. You're so kind.
Your question is which noun does whatever pronoun refer to?
Yep.
So you're literally just taking that, and then the paragraph is your text.
Right.
It's like, that's pretty cool. Like, I like that you can generalize.
I mean, there is no guarantee that this is going to work. This is like, you know, sort of like an off the cuff, like BERT fanboy trying to.
Well, so I mean, the fundamental difference, right? The squad Stanford whatever data set is it's giving you facts, right? And it's like, you know, the blue whale weighs 210,000.
Yeah, if you say how much does the blue whale weigh?
Yeah. Then, so the
reason it works is because like the answer is in the text. That's why I'm able to like. That's why I'm able to sort of roughly formulate the question like this. So
yeah, I mean, it needs to establish internally some model of the language being.
Well, that's what the pre-training is for. That's what like the BERT pre-training language model hopefully does for me.
Well, and that's what kind of differentiates BERT from like
word to vec or whatever.
Well, word to vec is just embeddings, but like BILSTM-CRF for like NER or like, you know, convolutional network for text classification is you're not so much like it's not as literal of a jump.
Oh, well, the BERT, I mean, BERT allows for transfer learning is sort of like what the paper showed, that you can have this base model, this language model, and apply to different NLP tasks, like directly through fine tuning, and that wasn't really, and the fine tuning generated state of the art performance, which is like the real differentiator. So real quick, I just want to just explain that we created the train examples using the pandas data frame, applying our create squad example lambda function on each of the rows, and that's done through axis 1. And we're using that exact design pattern to create the test examples. So if I go down,
could you just have done?
Well, the difference between train and test is that
just to create test squad example, or does it not implicitly pass that pass?
That might be implicit. I didn't, you know, I like explicit code sometimes. So that this returns a list of predict examples, and I updated convert examples to features. Oh, and see, like this has, so yeah, so this convert examples to features needs to be updated. Bam. So let's copy paste, and we'll see that. So you have examples.
So what are we doing now?
Tokenizer.
We already did the fine tuning, right?
Right. So what I'm doing now is
evaluate.
Yeah, we're doing evaluation.
So this is just plumbing bullshit.
Yeah. Plumbing bullshit. Nothing special to see here.
Where I was like running my mouth.
Yeah, before. Go ahead. Now you can run your mouth.
Just kind of spinning my wheels, right?
Go ahead.
If you want to do text classification with a convolutional network, which is like pretty much the only thing I know how to do, and I don't even know how to do it well.
Okay.
You have an output vector at the very, like you have your logit layer, right? And then you have
which predicts your label. Sure.
Which predicts your class, yeah. And then there's some normalization that happens, but basically it's just that last layer gives you your class. And on top of that layer, you have, you know, a convolutional network where you can have like a recurrent network or whatever. BERT, I don't quite understand what the hell is on top of it. It's just pure attention.
Yeah.
Just, what does that even look like? Like, what is? Because I tried looking at the tensor board of BERT just to see what the fuck it was doing.
Sure.
Crashed my computer.
Okay.
I was like, it's not built for that.
Well, it's not built for that. Hold on a second. So predict examples, append feature, not. So this is eval features. This seems to be circular. For example. Oh, here, this is what I need. Train writer dot. But this is for the training. When you do predict, you have a append feature, which uses eval features. Oh, it's just an empty array. All right, cool. I'm okay with that. I'm okay with that. It's complaining about indentation. Yeah, the code was the original code was written with just two line indenting, which is that's
why it's stupid to have a language that's written by white space.
Python is doing something right because of all the people. That's just all the people that write it. But it's sort of like JavaScript adoption, right? It's sort of just like a free for all.
I mean, that's my thing is when I write code at home, I do it all in Python every time. But I would not want to read other people's Python code.
Yeah, I can see that. So instead of train TF records, we're doing eval TF records, training false, so that we don't update our the weights. My guess is.
Wait. Never mind.
All right, so this should just work. Of course it doesn't.
It works.
Create test squad example is not defined.
No,
Touche, my friend. Touche.
What is this that you're running, though? Is this a Google collab?
This is actually Kaggle. This is actually Kaggle's Jupyter Notebook environment.
So
feature writer is not defined. Oh, that's probably because it's run squad. Yep, that feature writer. And we can, for edification, figure out what that means.
You just get the click commit and it commits it.
Yep, and then you have all these versions.
Why don't we have that? Can we do that? Can someone write that? Jenny.
You go to Google Cloud Engine.
Oh, that OCI thing you were talking about.
What's it called? Oh shit. So the issue is none type is not iterable. Oh. Oh, this copy pasting is failing me. Eval features. How is that used? Append feature. Convert examples to feature. Oh, the eval writer dot. Close. Oh man, this is because predict. Oh, totally stuck. So it's definitely this function. Input function builder. Predict features. So the length of predict features is nothing. There should be. Oh, I didn't have an input file name. Very interesting. Input file, eval writer. Huh?
That's what happens when you run Jupyter cells out of order.
No, this is just copy pasting issues. This is pure copy pasting issues. Input file. Because he rewrote the input function builder. That sort of makes me think that I shouldn't use it.
You rewrote the input function builder, so you shouldn't use his rewritten version?
Yeah.
Who's he?
The guy, the original notebook guy.
The original. So you copied a notebook and you also copied BERT code.
No, the notebook goes over BERT code.
So it's some dude showing how to like adapt the squad.
No, he actually did run classifier, and I'm adapting. He did BERT run classifier,
Okay.
and I'm translating that to run squad.
I
And
feel like you'd be better off just. Okay.
oh, just rerunning everything.
Just do it from command line.
Oh, do it from yeah, but
It's a pain, I know. But I've never had much success copying other people's notebooks unless like I was taking the entire thing. Because like, yeah. And also run classifier is inherently different from run squad.
oh, extremely inherently different. I'm really confused right now about predict examples. So let's run through this. Predict examples, tokenizer. Okay. Append feature. So I think the issue is the append feature. This shouldn't be eval feature. This should be, because it's actually the append feature is actually going here. Convert examples to feature. Let's just look at that real quick. Convert examples to feature, append features, and then eval features. Yeah, I want this stuff. Running predictions. I want to know this. I wonder if TF logging, is that like a thing?
Yeah.
I know, but like, will it do will it actually print? Or is there some like stuff I need to set up? Yeah. Eval examples doesn't exist. It's actually predict examples, which I agree. Oh, predict batch size. That's going to fail too. Predict batch size. I don't need it. This number of split feature. This is number of features. There are 730 features. Isn't that interesting? And instead of, yeah. All right. So yeah, what I was trying to do is figure out like the dependencies. No attribute label ID. Oh shit. There is no label ID in here. Zooks. All right, so let's check what the input IDs look like. That should definitely exist. So what I'm looking for now is in the BERT model. Oh, it's just input IDs, mask IDs, and segment IDs. That's it. And this is the, yeah, that's that code. So there actually is no label IDs. Interesting, of course, because this isn't, so I can get rid of that. Label IDs. Oh, so you were questioning about the input to BERT.
More the output.
The output. All right.
Well, I mean, what the hell does the algorithm look like? We've been over this once.
Second time's a charm.
Yes.
Let me look for label ID, because that does not exist. All right. Run.
What's up, YouTube?
I just want this to just work.
Big L, big A.
Streaming live. All right, cool. So it looks like it's running now and it's not complaining.
This episode is brought to you by HDMI cables.
All right, cool. So this is running. So let's talk about BERT. What does the output look like?
Now, what is the, like, what does that algorithm graph look like? computation graph.
Oh no, I don't know what that looks like. I can tell you stuff. I mean, yeah, this doesn't have support for looking at the computation graph.
I mean,
What I can tell you is that like, so the input text, right, is tokenized,
sure.
right? So that will look like, but there'll be like pound signs and stuff in it. Yeah, like this.
Okay.
Right, tokenized. So then that's all looked up into like their map. They actually have a token map. They have a dictionary. Token is, I don't know what this max context is.
Sure.
So, oh, the input ID is actually the index into that token map. I don't know what actually this token to orig map is.
Sure.
And then there's an input mask, right?
It's like a synonym map.
There's an input mask where they
Sure.
they separate sentences, and then they also separate segments. So
There's a segment.
Segment IDs. Well, let's look at what the original paper says about segments.
And the fact that they're doing input masking and stuff, like.
Well, that's because here.
Here we go.
So you have, this is the input representation. So given this input, that's tokenized, playing. You have the embedding for the word. You have the embedding for which sentence based on separator. Then you have position embedding. And that's the input. And then based on that, you can, to specify an objective so that what you're looking for is actually in different parts of the output, right? So what happens is, given this input, it generates a separate token, a set of tokens, specifically around squad. It'll generate a set of tokens. Then everything after the separator token that's generated, eventually it'll happen because of math and training. Everything after the token will actually be the answer to your question. Oh, this is TN. It'll actually be your question separator answer. Question is 1 through N. Paragraph is 1 through M.
So my understanding from, like, for example, the classification, right, is it's similar, at least spiritually, to like if we're training a recurrent neural network, right, to do classification, it's going to perform poorly because it's recurrent. But it's like you have this side here that's your input text. You have your other side, you have a separator, and you have your other side where one of these things is going to be a 1, and the others, it's essentially probabilities.
We're talking about classification.
Yeah, for classification.
Okay. Are you talking about in BERT?
No, not in BERT. Today, if we're just doing classification with a recurrent neural network, it looks like that, right? We're doing a bad job because of distance problems, of vanishing gradients, whatever, but it gives you a output like vector like this, where the first half is your input, and the next half, or if you're doing sequence-to-sequence modeling, like neural machine translation, you have your input sequence, and then you have your separator, and then you have your output sequence.
Yeah.
There's a whole bunch of bullshit that has to happen because your translation might have a different number of characters, different number of words, whatever. So you have to do masking and shit to get like that dynamic sizing of the output and the input. But essentially, you are filling up a brand new vector with your translation.
But like that vector of the new translation, like, so at the end of it, so what you're talking about is like an encoder decoder with sequence to sequence.
Yeah.
So sequence to sequence, and then TensorFlow has a really great diagram.
Yeah, that would be helpful. So my understanding of BERT and the classification, or at least what I'm assuming, because it seems to actually want like names of classes, is that it's doing an encoder decoder thing with classification too, which is kind of weird to me.
Sequence. Usually there's like a drawing. Oh no, that's not it. Current neural network. Neural machine translation. Yeah. Sequence to sequence. Blog post. Yeah. That's what we want. So
There's the picture.
There's no picture. How am I supposed to explain something if there is no picture? Oh no.
Try the NMT tutorial, maybe that has it. Or maybe the GitHub page has it on there somewhere. Just keep scrolling down.
Oh yeah, down here somewhere. Dude, here it is.
Wait, there it is.
Yep. So you take in a sentence,
Down
encoder.
Wait, yeah.
So this is the unrolling of the LSTM through time. Or yes, no.
Yeah, I mean the vertical is the unrolling of it.
Yeah, the vertical is the unrolling. Yep, the vertical is the unrolling. And then what happens is at this point, this projection, target output words.
That's the output. The projection layer is the answer.
Layer. Hidden layer. I am familiar of thinking about it like this.
Okay, then we'll go like that then.
Because I don't know where this vector exists.
Those are the weights.
So that it might be, that vector might be here, right? That's where blue transitions to red. And then at the, I think, the encoder, decoder,
sure.
And then this will be in between these two spots is like your thought vector, right? Your stop is like your thought vector.
Yeah.
And then that's used to predict a word, right? The output from the last unrolling for like each input word is then, right? So the projection layer is predicting which word in your dictionary is being used, which word in your dictionary is being predicted based on the output from the last LSTM. Like this LSTM, right? This input, it predict this V, right? That's the size of your vocabulary, right? You project to this thought vector projects over your dictionary, and the highest number is the word that you're actually pulling out.
You're taking the blue shit, you're feeding it into weights and math, and you get the red shit out of the weights and math. And the way it's training is by filling up the red shit from the blue shit.
Right.
There's some magic that happens in the middle there that turns the blue shit into red shit.
It's this the stop token.
Yeah. And the specifics of how that works, like the updates of each LSTM layer and all that, and unrolling LSTMs is essentially a computation thing. And that's that's a convenience that for some reason they like to belabor the shit out of, that neural networks have to do that because they can't,
Oh, this has been done. So what happens next?
But I don't understand how BERT is coming up with classification answers. Is it like that? Is it like a sequence to sequence answer?
Because I mean, eventually, yeah, you're going to predict over your vocabulary. You're going to predict over your vocabulary. I actually don't know if this works because this is purely predict probability. I'm pretty sure what I have to do is go back to squad.
I would just tweak this file and then run it. Reintroducing unnecessary complexity.
Yeah, the thing is, in order to generate your output, you have to. There's like a, what is it called when you span or you're not engram, beam search. Don't you have to do beam search and shit like that for generating your output?
That's what I was asking.
Anyway,
I don't understand how you go from a language model to a classification. I don't know what math is being crunched together to do that.
So predict batch size being used. Estimator.
I tried stepping through the code before, and it's all this bullshit about TPUs that nobody on Earth cares about outside of Google, and it's compartmentalized.
Oh, here's look at this. If running eval anyway.
Yeah,
I'm pretty sure I can just copy paste this.
I know that the tabs are right.
The tabs are not going to be right. That's for damn sure. But this is all trash because there's predictions and then results. That's good to know. But
TPDM is important.
Is it?
Yeah.
Why?
Because it draws a progress bar.
Oh, is that what it does? So there's a predict input function. Boom. Oh, this is actually predicting for a single example. Results. No, it's not. No, it's not. TF logging. All right. Unique ID. I believe that. What the hell is going on with this indenting?
Yeah, that's annoying. No, maybe the if isn't inverted properly.
No, it's
maybe 4 isn't inverted properly. Oh, just
so
everything below it isn't inverted.
4. So it's if TF and then everything else is under that TF logging. Yep. So that's this stuff. The nice thing is you can actually go like that. Whoops. Whoops. All right, cool. So all results. I wonder what this all results looks like. Yeah, at the end of the for loop, you have all results. Output dir.
Yeah.
Indeed. Right predictions. Yeah, so you need like end best size, max answer length, do lowercase. Yeah, you need like all that. So instead of output dir, I'm very interested in what this is all going to look like. Output dir look like nothing.
Oh yeah, but I'm really interested.
This is pretty much, I'm sure it's going to be run squad. Right predictions. It's not eval examples. Isn't it like, oh, it is, it is predict examples. Anyway. Predict examples, eval features, all results, and best size. What's the default here? What are the defaults? 20. Max answer length, 30. I'm just using the default values from. Yeah, so like this is pretty much like my first pass to make sure like all my plumbing works before I actually like start taking for serious, you know, my results and all that stuff. True.
And your results look so cool.
I don't know. We're like we're in it together.
So yeah, now it's training day.
Unique IDs. Why isn't that? So I'm interested what results look like. Print results. Interesting thing. It might be failing because we already consumed the input function. So why don't we recreate it? Well, TensorFlow like 1.0 or 2.0 or whatever is going to be like a real like eager execution, et cetera, et cetera. Unique IDs doesn't exist.
They need to write a programming language for default.
Isn't that what TensorFlow is?
No.
What is it? What about Keras?
Keras is not a programming language.
But like, oh, this is actually in run squad.
A language that compiles into a computation graph. That's that one. And it has to be like It has to be Facebook. It has to be Google that makes it. It can't be some bullshit startup. It has to be a big company with a lot of buy-in and the expertise to write a language.
I don't think they're gonna create a like. What would a language do?
A language would make it so that you don't have this magical intermediate stage where you have a static computation graph that's defined in another programming language than the one that you're writing in.
But the whole like static computation graph is all like not.
It's hardware.
It's not gonna exist. It's not gonna exist in TensorFlow 2.0. It's all gonna be like eager execution and all that. Like you won't need to think about the computation graph anymore. The idea is.
I mean, I'll believe that when I see it.
Okay.
I mean, that's why TensorFlow eager execution is just like you'll be able to evaluate parts of it beforehand. Like it'll be kind of a bit more like PyTorch, but even PyTorch stuff suffers from that issue of like you can't optimize stuff unless it's statically precompiled, unless you know what you're going to be doing ahead of time. So it has to be like a strongly typed compiled language. Now I'll take away all the crap where like you need to know what type every single thing is. You don't know what like properties it has because there's no typing.
I think this is what I should be doing.
Gianna Kuhn agrees with me. It looks like a frog.
How come? Interesting thought. It does all results. And it does a predict input function. Yeah, I'm not bought into this thing here. I think this should be run squad input function builder. So that's a thing. And then all this stuff afterwards is A-OK. Yeah, I'm pretty much just going to take what's in this predict stuff. So how do I make this the next screen over? Oh, very easily. So yeah, I don't need this input function builder. This is not bringing me nothing but just heartache. What time is it?
2. You have a clock.
No,
I'd say we give this another like
10 minutes and then call it a day. All right, so we create eval examples. Let's really just conform. So we create eval examples, feature writer, eval, creates an eval writer. You have eval features. You append to your eval features using append feature and the eval writer. You don't need to call convert examples to feature. The append feature function will actually append to your eval features. We want to close our eval writer. Okay, cool. Do that. Do some printing. Then all our results. Yeah, so then you have an input function builder, writer name. We don't need eval features anymore. Math sequence like false, false. Estimator. So we don't need to predict. That's not going to do anything. All right, so let's run that. That's done. Then the next part is all result, and I pretty much copy pasted this stuff instead of all results. For result estimator predict info function. Yep. I don't need to print results. That's fine. So, but now the unique ID and all that stuff should work. And instead of predict examples, it's now eval examples. No. Why don't you work? Because unique IDs don't exist. That's real interesting. I thought I only got rid of label IDs.
All you want to do is semantic role.
But unique IDs.
Right? You want to be able to say she is, Stacy, and not he is Stacy, right?
Yeah. Yeah. Yeah.
So any semantic role labeling system should be able to do that, right? Like by definition of what semantic role labeling is. The Kaggle competitions are usually somehow like a little bit unique, aren't they?
Yeah, like, is this a problem that hasn't been solved? Is your question?
Yeah.
I don't know.
I feel like it's just a really like boring.
Or not. I just want to see if I can use BERT to solve another kind of problem. And I'm sort of failing right now because results doesn't have. This is going to be like my anticlimactic ending.
You're failing because the reason, like, the way to do this is to go into the code and to modify the script that actually transfer it.
Yeah, so let me try to print. The input IDs are right there. Oh, it's actually empty. Look, the result is empty. So look, if I say tf logging info.
What's the difference between tf.session and tf.interactive session? Are you using an interactive session right
I don't know.
now?
Yeah.
I've never gotten TensorFlow to work.
No, this is not an interactive session. This is like definitely outside of all that.
Yeah, I've had a lot of trouble getting it to work in Jupyter.
Oh, really?
Yeah, I mean, it's pretty commonly done. I'm not saying it's impossible, but I've like had issues with like being able to feed stuff through. Like Jupyter needs to know when something return.
Oh, I mean, that's what the estimator API is for, to fix all that. Use estimator API, you don't need to
So here's a question for TensorFlow eager execution, whatever 2.0.
Sure.
You're saying that like they don't need their input anymore. You still need to write serving input receiver functions in TensorFlow 2.0.
Question? Say that again. Serving
input receiver functions. Because the fact that you need to write serving input receiver functions is why like TensorFlow and like Python is
serving eager input functions. No, that's all estimator API stuff.
Yeah, that is the estimating API.
So like serving, yeah. So if I look here, there is no serving.
But if you don't have an underlying statically defined function graph, like
that's what like the input function builder is for, I think.
Yeah, you have to build an input function. You have to build a serving input receiver is something that takes your TensorFlow serving input and it transforms it to whatever your computation graph expects.
Oh yeah, yeah.
So
I mean, yeah, something to translate your raw texts
into a protobuf that TensorFlow is not.
Yeah, I mean, yeah, I think that's like par for the course of this. You can't get around that because like
wrote an actual dedicated program.
But this is all about like efficient representations of like your underlying data. This isn't about like deep learning representations. Like how do you translate like a paragraph into numbers is the question. That's the question I'm trying to like.
Yeah, we're asking two different questions.
Okay.
I'm still like, oh, no, where's the?
It's still feeding, except.
Thank God.
Yeah.
Followers, service, and hit me up on Patreon.
Yeah, man.
That's what you should do.
Patreon it?
Yeah.
Dude,
like, donate to my channel.
I would totally be for it. What I don't understand is how come unique IDs doesn't exist. So that must mean. Okay, I have a question. Yeah, I'm totally lost.
I've dropped down to like 2%. I'm still angry at TensorFlow for existing.
The thing is, so here's the model, input function. Yeah, the thing is, I'm using the run squad feature writer for the train writer. And then I should do the same thing, run squad feature writer for the eval writer. Eval writer dot file name is training false. Yeah, I'm just very confused about like, it's talking about this attribute that doesn't exist, but it should exist because, ooh, I like errors. I can fix errors.
Do you have like people watching this right now, or are you just gonna upload it later?
I'm gonna upload it later.
Because if you had like an audience viewing your stream, you could make it interactive. Be like, should Leo look at this or look at
So yeah, this idea was from like that other like Kaggle broadcast where they like read the paper. And I was like, why can't you just do that with like code?
I think she has.
And she also has coding, so then it's a complete riff. It's a complete just. Oh, batch size. All right, cool. So batch size doesn't. Where is it getting? All right, so it's just like stupid Jupyter Notebook, crazy stuff that I was facing. Input function, batch size. All right, input function. Is there a eval writer? Yeah, I don't know why it's asking about batch size.
All right, like, okay, what's going on? Where's it asking me that?
Thanks for jumping in. So it's asking me in predict input function. Yeah, it's asking me here. But the crazy thing is, over here they don't talk about batch size. But over here,
So
the predict, see the predict, right? And then it goes into.
That's inside TensorFlow, right?
No, but I think like if I just add batch size as a param here, it'll just like work. So if I just do input function batch size, it probably has to do with the fact that like there's like a flags thing here that doesn't exist in this execute paradigm. That's like the biggest issue. Nope.
Oh, you're not doing stuff with TensorFlow flags?
No, yeah, I'm not messing with TensorFlow flags at all. So this is run squad input function. Who's calling this? This is by the TPU estimator. That's fine. That's fine. That's fine. I wish I could.
So where is the code that's correct?
Oh, maybe predict. The code that's correct is supposed to be on the right.
And your code is on the left?
Yep, my code is on the left.
And that's the same you're defining predict input function.
Yeah, input function. Yeah, there's nothing here about batch size.
Where are you calling input function? Batch size not mentioned at all on the right side, ever?
This is what, so if I go, no, it's definitely used.
Flags, all right.
So it looks like, yeah, this is an error. This is like, this is an issue because, what's it called? The actual input. Batch size doesn't exist in params. Look, there's only one instance of batch size.
But params is TF flags, right? Or is that a dictionary? What is params? Where is that defined? That variable?
Input function. So the DF decode record. No, that's just another. So where's input function?
Yeah, where's input function ever called?
So you call an input function by saying input function. There's a input function.
Input function is that. So estimator.train. Where's the estimator's?
You know what I think
estimator being instinctual?
I think it has to do with
We got it. Wait, where's the estimator? So
the estimator.
Estimator.train. Go to that line. Go to estimator.
So I mean, like I'm in this function builder here.
Go to where the estimator is instantiated.
Which one?
So you have line 1215.
1215.
That estimator right there. Where does it come from?
I do that. Here, TPU estimator. But it like defaults to CPU. Ooh, look at you. Did you
Damn!
Did you
run config is where
I mean right there, you got batch size. Oh, you know what? I bet you there's also a predict batch size. Oh my goodness. Whew. That's definitely it. Definitely it. Definitely. 100%. However, I'm pretty sure that, yeah. How do I save this? Save. Because I'm using the predict and not eval.
What's the error? Drop remainder type error. Input function builder got an unexpected argument. Because you didn't delete that thing that you had.
Dude, that's totally. Look at you. You TensorFlow estimator expert.
I've used it. I'm a TensorFlow estimator survivor.
And then this should now run. Yeah. 47.
Be sure to like and subscribe.
Yeah, that's it. Except it fails. Oh, because raw result doesn't exist.
Yeah, well now at least we get to the easy mode errors.
Run squad. Oh man, I don't know if I would have figured that out.
You would have.
Yeah, maybe. I've come across that error before. Look at that. Look, numbers. This is what you wanted.
You would have figured it out, but before you figured it out, you would have become as angry at TensorFlow as I am.
Look, the logits.
Bad logits.
Unknown command line F.
What? Look at typo in this.
Oh, it's right here. Flags version with negative.
What does that mean? Why is that in production code?
This is because there's actually two versions of the there's actually two versions of the code. There's two versions of the squad dataset. There's a version 1 and version 2. So the right predict. So I don't care about right predictions actually. I mean I do, but I don't.
It's whatever.
Yeah. I guess I want. I guess I should just rewrite this. Just copy paste this right predictions. Oh my gosh, it's so huge. So yeah, this is what I was talking about with like. You have to get your predictions. You have your start logit, end logit. You do some stuff around. If it's, I don't know. Hold on a second.
Why do you keep doing if continue with else if?
We can hypothetically create invalid predictions. Predict that the start of the span is in the question. We throw out all invalid predictions. All right, cool. There should maybe be something in here about Beam. Detokenize word piece. Clean white space. Yeah, I don't know what this end best prediction is. total scores, probabilities, compute softmax. This is a really long function. Yeah, that's like the meat of it. At n best prediction, named tuple. But yeah, so this really long function is how they generate that output answer text. And so there's a whole bunch of references to this flags with v2 negative. Oh my gosh. So I should probably just copy paste and redo that myself.
You can go home and take this video and edit it to the point where I looked up from the phone game that I was playing and said, okay, what the hell are you doing?
I probably need to create a cell now. It's a lot longer than I thought it would be.
What is
It has to have been an hour. I usually like making it an hour.
The last time I heard about beam search was in some videos watching some lecture. You know, there's a lecture series on reinforcement learning out there on the internet, and I was all excited to because I'd like to do reinforcement learning. That stuff's cool. And the first 6 lectures are on this is what we used to do, and then the last 2 are on actual reinforcement learning circa 4 years ago. And then you walk away with outdated knowledge on stuff that nobody cares about. That isn't.
Wait, were you using that Java reinforcement library? You know what I'm talking about? It was like created at Brown.
No.
Oh, okay.
This was it's some dude at DeepMind or something giving me a course. I mean, he was clearly really smart. It's just academia is not well suited to a field that's fast. Because he's talking about this is the problem that we're solving. I think 3 entire lectures, it was probably close to 6 hours, was just devoted to describing the problem that needs to be solved.
If not, else it is.
Other people going into education to be educated about something should already know the problem that needs to be solved. You need to explain the problem that you're trying to solve to them, then they should take it.
Huh, that worked. This should be like that. Collections is not defined. Oh my god. Where is... Oh. Oh, I again need the BERT. I think I could just import collections. I'm pretty sure collections is part of something.
Yeah, there's it's built into Python.
What?
Collections is built into Python.
Right, but just import collections. Yeah, just indexes is not defined.
There might be a TF collections. Yeah, there is a TF collection. Sure.
Indexes. Yep. Now we can straight copy paste. You've gone down the rabbit hole.
One of the other problems I have with TensorFlow is the stuff in the TF-contrib library. It's not actually in the TF-contrib library. It's defined in their package file or whatever. So you can't jump to definitions. You can't get code on demand for anything in TF-contrib because it actually lives in a different place. Everything in TF-contrib is an alias for something else.
Yeah, I think they're getting rid of.
And I used it very heavily. If you need to actually use code, you need TF-contrib. Those are all experimental features that are not covered by API stability guarantees. So they change and break constantly.
Get final text. Oh, that's the money shot right there. Get final text.
Is that the money shot?
That's right, man. What I said.
Is that what we're watching now? The money shot.
That's the shot that's going to get you all the money.
Exactly.
Oh my goodness. nothing is in this file. Run squad. Wow, this is like, so like the other version that I do is, what I do is I actually alter the original. I fork the BERT container. I fork BERT, and then I fork BERT. I fork BERT. I make changes, and then I push changes to like a branch of my fork. Because at the beginning of this, they actually just do like raw. They do a raw checkout of like the content. But anyway. All right, I think that's it.
All right, we're done. So you solved the problem.
I think if I like, let's see what this stuff looks like.
Looks like
You.
Oh, the answers?
Yeah.
Yeah. Did we get it all right?
Yeah. So if we go back to what's the original? I think the original data frame is called train DF. Yeah.
What do you guys think of self-driving cars?
Dude, I can't wait to buy one and then possibly die in it. I can't wait to be the self-driving car martyr. What do you mean? So train DF full, and then we want like this one. All right, so we can say train DF full dot ID equals. All right, double equals. Cool. And then is impossible. It is impossible. All right. So, but was Sakura part of these two? Nope. All right, cool. What about 986? Answer is Batman. Holy shit. And then the answer is Two-Face. Oh, that's sad. But it's one of them. All right, cool.
I mean, it's the right gender at least.
I mean, but that's like the ant. That's like you know what you get anyway. Rita, Indiana.
Got it.
Woo. All right, so I need to like
getting, like, names.
commit this.
Good. Do we get money for this?
I think it's fine.
How much?
25,000. Dude, I didn't think this was gonna work. That's like for real, for real. I didn't think it would get anything. I thought it would just be shooting into the dark. Yeah, man. Percy Ali.
All right.
And then for 1104, it's Charles. See, but it predicts Charles and not. All right. So yeah, a whole bunch of analysis on the predictions. Save this.
There was no original answer text.
Yeah, so it is impossible true. So like, it's not either A or B.
I mean, that's bullshit. Why? Why would you put that in like the? I don't know.
All right, guys, that's it for today.
Like and subscribe.
Yep. Next time we're gonna analyze results.
Hit this button on the top left to subscribe.